As we continue learning about MapReduce, I want to add some more context to our visualization as we get ready to start coding. So we see that we have input starting on the left side. And the first step is going to be splitting that input so that it can be chunked or processed physically onto each of the map nodes. Now, there is a default method in the MapReduce API that you can use, or you can override it depending on the type and size and processing that you're going to be doing to the data. Then the mapping code will execute. You, of course, write the map method. The shuffling is done by default along with sorting, but can be overridden if business needs necessitate. Then the reducing code is executed based on your logic, and the final results are aggregated. You also write that code. So if you look at the diagram, the code that you're going to be writing for every MapReduce job is the mapping logic and the reducing logic. Optionally, you can override the default implementations of the other phases. The MapReduce ecosystem is evolving. You may remember from earlier movies that MapReduce itself is more than 10 years old. So version 1 is very commonly in use. It's been out there for a while, and it's under the top-level library org.apache.hadoop.mapred. Version 2 has been out for a few years and is slowly starting to be the standard. At this time, however, you're going to see production code in both versions. Now, some parts of the API are almost identical, and some other parts are quite different. So we're going to start with version 1. But again, this is just a tip when you're looking at sample code. If you see org.apache.hadoop.mapreduce, you're looking at version 2. So you want to be really careful to not mix your code and to really understand and research which version you want to work with in both proof of concepts and production environments. So in addition to the MapReduce API, if you're using HDFS, or really any other parts of Hadoop, you're going to have some other libraries. And I've listed the core libraries here. You can see that they all start with import, org, Apache, Hadoop, assuming Java for the import. And then we have the file system paths, the config, the IO, and the util libraries. These are really common libraries, and there are more that you might use, many more actually, but this is kind of like a baseline. Now, because I tend to write only with MapReduce 2 code, but I wanted to start this course with MapReduce 1, we are now going to review the code used to write a MapReduce job with the version 1 of the API. And we're going to break it down part by part. So we're going to start with the map class. So I want to point out a couple of things here. You can see the class is static, as I mentioned in previous movies, and it extends the MapReduce base. You'll notice that the types are familiar but different. So we have the mapper taking 2 text types, but 2 types that have the word writable, long writable and int writable. And as we delve into this, it'll become clear why. Then we have private final static int writable initialized to 1. And then we have a private text, word, new text. This is our key and our value. You might remember for word count, you have a value of 1 for each word that we find. That's what the int writable is, and the text is the actual text of the word. So now in our map method, public void map, we have a long writable, which is the key, and a text, which is the value. Then we have an output collector, which takes a text and int writable output, and then in this case, we use a reporter for status. And then we throw an exception, a file exception if we can't access a file. Then we have a string align, the value to string. And then here we have an interesting utility class, string tokenizer, and we create an instance of it against the line. So what does this do? This is one of the utilities in the MapReduce API that breaks down words. Now, if the default method of breaking down lines into words is adequate for your business case, you can just use a string tokenizer. But many times in production situations, you have to extend or perhaps replace because of either performance or the logic isn't exactly what you're looking for. Maybe you have foreign characters. Maybe you have some considerations that the default string tokenizer doesn't take into account. And then you have a while loop while the tokenizer has more tokens. Then take the word and set the tokenizer to the next token, and then collect in the output collector word and 1. So what this does is this runs on each one of the physical nodes, and it takes the chunks of text from the HDFS file system by default, and then breaks them into a set of key value pairs, the text of the word and the number 1. So the next part of this is the reducer code. So again, we have a public static class reduce, which extends the MapReduce base, and it implements a reducer, taking text and int writable and text and int writable. And it implements the public void reduce method, taking text key, an iterator of int writable, the values, the output collector of text and writable, the output reporter, and throwing the file exception. It creates a variable called sum with an initial value of 0. And then we have a while loop. So we look at the values and we run the hasNext method. So then we take the sum value and we plus equal, which is sum plus the values, next get, and add it to the sum. So it's a collector. And then we pass that output collect, the key, new int writable, the sum. So what that means in English is we're aggregating or we're counting up the number of words of each type. To run this in MapReduce 1, you write a main method, and inside of it, you create an instance of job configuration or job conf, and you pass in the WordCount.class. And then you set the job name, set the output key class, the output value class, the mapper, the combiner, the reducer, the input format, the output format, the file input format, the file output format, including the path, and then you run the job. What is this combiner class? It's called a local reducer. What it does is it performs an aggregation or adds up the keys and values on each node so that less traffic is sent across the network to the reducer. Let me make an example. Let's say you're processing some text. So you have the word the, and rather than sending the key and value, the one, 100 times or 1,000 times from each node, if you run a combiner, you'll send the 100, the 101, the 102, so on and so forth, the count of it across the network, which can really improve performance. Now, the interesting thing about the combiner is it's not guaranteed to run. It's an optimization. So it is optional, but it's a really common pattern, and so I left it in here. So the key components of the Java implementation of MapReduce are the input and output, and I deliberately didn't go very deep into the write and write comparable at this point. I'm going to do that coming up just in a minute here. And then we have the mapper, reducer, the partitioner, the reporter, and the output collector. Those are the key components. Now it's time to talk about those writable data types. You may remember that I talked about HDFS files as being immutable. So how do we perform looped aggregations? Well, we have special types, which are extensions beyond the base Java types, and they're required for MapReduce. So you can see them listed here. So you've got everything from a Boolean writable all the way to a long writable. And you can see that text doesn't have to be designated as a writable. All the numeric values do, though. And notice they're described as wrappers. They're wrappers for the Java primitives. Notice the last entry in the chart, your writable. For some situations, it makes the best sense from a performance standpoint for you to write a custom type. To do that, you would implement the writable interface for a value or the write comparable of T for a key. Notice you would also have to define a sort policy for your custom writable. So there's quite a bit of code to write, although there are some good samples out there. So what would be an example of that? Perhaps like a geospatial type, where you have lat long or some combination of point in space or time that doesn't aggregate or sort in a way that is natural for the primitive types. So as we're looking into the detail of MapReduce, another consideration is input types. So you can see in the table here that I've referenced some of the most common ones from text, key value, sequence file, and end line, and just giving you a little bit more detail. And this is just based on, again, my experience in working with Hadoop in real-world situations. Text is obviously the default. So it gives you the description of it. Each line in text is a record, and the key is a long writable, the offset of the line, and the value, text, is the content of the line. And again, the main reason that I gave you this information is so that you can determine if you can use pre-existing types or you need to provide some additional business logic or do some pre-processing on your input into Hadoop. And just to contrast text input, let's just take the next one, key value text input. Each line is a record. The first separator divides each line. The separator set by key.value.separator.in.input.line property, the default is the tab. Key is text is anything before the separator. Value is text, everything after the separator. So again, these implementation details are really, really important when you're writing your MapReduce job. So you're going to need to dig in and look at not only the default input types, but you're also going to consider what is the data coming in, what kind of pre-processing, if any, do you want to or need to do, and how might you need to override or use different kinds of types than the defaults if you're unable to or just doesn't fit your business scenario to make any changes to your incoming data so it matches one of these input types. As with input types, I wanted to talk a little bit about output types. So I put some of the most common ones here. So you have the text output format, which is key value, the sequence file output format, or the null output format. So the text writes each record as a line of text. Keys and values are written as strings and separated by a tab, which can be changed in the MapRed.text output format separator property. The sequence file output format writes the key value pairs in sequence file format. It works in conjunction with the sequence file input format. So if you change one, you change the other. Now, the null output might seem really, really strange. You might be surprised to see the null output format, but there are business conditions that warrant that.